Hey everyone, welcome back to the channel. This is Rahul. In today's video, we are going to tackle another interesting Leetcode problem, that is maximum absolute sum of any subarray. Actually, it's a great way to understand subarray sums and optimization technique. So, before start, if you are new here, subscribe my channel for more DSA and coding contents. And you can ping me if you have any doubts or any query regarding this. So let's start. Here we are given an integer array nums, and the absolute sum of a subarray is the absolute value of the sum of its elements. So our goal is to return the maximum absolute sum of any, means possibly empty subarray of sums. So if you see here, subarray means adjacent ones need to be there. So let's take those. So here 1 3 minus 3, it will give result of minus 2, which absolute is 2. Like that, if we check for all, the only elements that will give is 2 and 3, which gives a sum of 5. Here also same. Here this minus 5 1 minus 4 is the biggest one, because it will give a sum of minus 8, which the absolute make it positive. So that's the thing we have to do. What whichever, if it's negative as well as positive, during sum we get a higher value, we have to take that, and we have to con- uh, remove the minus using absolute. That's the thing we have to do. So now I discussed regarding how and what we have to do. Now, let's discuss the different ways to solve this problem. So, as the normal thing, first approach is brute force. Here we have to check all possible subarrays, and we have to calculate their sums. Then we have to keep track of the maximum absolute sum, as well as the time complexity will become big of n square, because we have to check all subarray, and it is not efficient for large inputs. If it's small, means it was not that much a problem. The approach that we are going to use is cadence algorithm. Here, instead of checking all subarrays, we maintain two running sums. That is, we will use max sum as well as min sum. Here, max sum tracks the maximum subarray sum, and min sum tracks the minimum subarray sum. It will capture large negative sum. That's why we are using min sum here. Then we will return the absolute of the subtraction from maximum by min sum, which gives the highest absolute sum. So in this approach, since we traverse the array once, it becomes more efficient and gives big of n time complexity. That way, we are choosing this approach rather than brute force approach. So let's start with our coding part. So first of all, we have to initialize one variable in order to keep track of the running sum. So I will name it as sum. Then we have to initialize min and max to track the minimum and maximum prefix sum. Maximum. So once this done, the next step we have to do is we have to traverse through the array. For int I is equal to 0, I less than n, I plus plus. Here nums dot length we have to give Okay. So first of all, we have to add current element to the running sum. So sum plus equals nums of I. Okay. Once this done, we have to update max sum if the new sum is larger. So if sum greater than max sum, then max sum is equal to sum. Same like this, we have to do for min sum. Means if the update, if the new sum is smaller, then we have to update min sum. If sum less than min sum, sum. Okay. So once this done, we have to come out of the loop and we have to return the maximum absolute sum, which will calculate as the difference between maximum and min sum. So we will use the math function return mat dot absolute of maximum minus min sum. Okay, so the things I done here is first of all we initialize the variables that needs to keep track of the running sum, then min sum to keep track of the to store the smallest prefix sum, max sum for storing largest prefix sum. Then we iterate through the array and we updated the sum. If sum exceed max sum, we have to update max sum. If sum drops below min sum, then we have to update min sum. Then we are returning the absolute of the difference between max sum and min sum using the math function, the absolute. Okay, just run it. It's working. Submit. See, it's working perfectly. Now let's analyze the efficiency of our solution. Since we traverse the array once, we have a time complexity of big of n and space complexity is big of 1 since we use only a few extra variables. This approach is optimal because it keeps tracks of both the maximum and minimum prefix sum in a single pass, making it linear in time. Unlike the brute force approach, it doesn't check every possible subarray, making it significantly faster. And that's it. We have solved maximum absolute sum of any subarray using Cadence algorithm. If you found this helpful, don't forget to like, subscribe and hit the bell icon so you never miss an update. See you next one. Till that, happy coding.